Hello guys, welcome back into the mathematical lesson whereby we will still be continuing with these problems of Euclidean geometry. So in the previous lessons, we left off in this problem. So we will be having a look on this problem on how we can answer this problem. So always, you will read the statement and follow with the technique Dr. Cape Town, and then now you can freely jump into the problems and answer the problems. Now, let's read the statement before we can go to the Dr. Cape Town technique. The statement says to us, in the diagram below, AST is a tangent. This is a tangent to the circle with the center O. There it touches the circle at S. Then an angle RST is equal to S1. Angle S1 is equal to 60 is equal to 23 degrees. Okay. QR, which is this line, is equal to RS. Therefore, this triangle is an isosceles triangle because these sides are equal. Now, this angle will be equal to that angle, reason being angles opposite equal sides, right? Okay, now we are done using the information that we are given. Now let's use the technique of ours, DRCPT. DRCPT, okay. D, diameter. No, there is no diameter in the diagram. R, radius. OS is the radius. OQ is the radius. Therefore, OS is equal to OQ radii. Therefore, now a triangle SOQ is an isosceles triangle. Therefore, angle S3 is equal to angle Q2. Reason being angles opposite equal sides. Okay, and we have a radius and a tangent here. Therefore, this angle here will be equal to 90 degrees. Reason being a radius is perpendicular to the tangent. You guys know that theorem. Okay, we go for the C, a cyclic quad. I see here is a cyclic quad with 4 vertices of this quadrilateral on the circumference of the circle. Now, angle P and angle R are supplementary, and this whole angle and that whole angle are supplementary, right? Okay, and then we are done with the C. We go for P, parallel lines. No, there are no parallel lines here. We will proceed to the next one. T, the tangent. There is a tangent and there is a triangle. Therefore, we can use a tan chord. Okay, this angle between the tangent and the chord is equal to the angle inside that triangle that is opposite the chord, right? Okay, and also this angle between this tangent and this chord is equal to the angle inside the triangle that is opposite the chord, which is this one right here, right? Okay, I think we are done using our analysis. Now we can just jump into the problems and see what we are required to do. Okay, let me erase this. Okay, and have my blue pen ready. Calculate with reasons the size of angle QSR. QSR. This is Q, there is S, this is R. Oh, this is a beautiful, beautiful, beautiful question. Now, with reasons. So guys, always in Euclidean geometry, you will put the statement and accompany that statement with a reason, a valid mathematical reason behind that statement that you just stated. So let's go. We will say this angle S1, not just S1, but angle S1 is equal to that. We saw that when we were using a DRCPT, that S1 is equal to Q1. Because this is the angle between the tangent and the chord. We go to this triangle, we go to the angle that is opposite the chord, which is that one. Q1 is equal to 23 centimeters, right? Yes. Now, reason being a tan chord theorem. A tan chord theorem. Yes. Now, we have this angle here. We were given that this side is equal to this side. Then we said that implies that the triangle SRQ is an isosceles triangle. That forces this angle S2 to be equal to angle Q1. Now we will say angle S2 is equal to angle Q1 because those are the angles opposite equal sides, right? Yeah. Now we have this angle. Remember, we are looking for QSR, which is exactly equals to angle S2. Angle QSR is exactly equal to angle S2. Therefore, this is the answer for question 10.3.1. You will have your mark allocation like this. The statement, the reason, the statement, the reason. You get your beautiful 4 marks. Now, let's proceed to the next question, 10.3.2. Now, we are required to find the angle R, which is this one. Now, this is the triangle. Remember, the interior angles of a triangle are supplementary. Therefore, to find R, we can simply say 180 degrees minus S2, which is just 23 minus Q1, which is 23 as well. What is the reason behind this? It is because the interior angles of a triangle are supplementary, and then this will give me 180 degrees minus 23 minus 23 is 134 degrees. Okay, this is 134 degrees. We go to the next one, 10.3.3. We are now required to find the size of angle P, which is that one. Remember when we were at C here, we said that is a cyclic quad. Now we talked about the cyclic quad. We said the opposite angles of a cyclic quad are supplementary. And we mentioned that angle P and angle R are supplementary, meaning angle P plus angle R is equal to 180 degrees. Therefore, angle P is equal to 180 degrees minus angle R, and angle R is equal to 134 degrees. That is equal to 180 degrees minus 134. I get 46 degrees. What is the reason behind that? Opposite angles of a cyclic quad are supplementary. Just like that. Okay, we go to the next one. 10.3.4. We are now required to find the size of angle O1. This is O1, and O1 is at the center. Using theorem 2, angle at the center is 2 times angle at the circumference. Therefore, angle O1 is equal to 2 times angle P, which is going to be 2 times 43 degrees. Then it gives me, no, not 43, this is 46 degrees. 46 degrees. I'm sorry for that, guys. 2 times 46 degrees. I then get 92 degrees. What is the reason? Angle at the center. Angle at the center is 2 times, oh no, let me write it like this, is 2 times angle at the circumference is 2 times angle at the circumference. How to write circumference again? Oh, circumference, right, yes. So, oh, I'm sorry for that. What is happening now? Now we are done with question 10.3. Now, we still have time, and I promised to do this question in this lesson. Now, this is those proofs of the theorems. So now we will be proving that angle P and angle R are supplementary. So they are saying to us, in the diagram below, O is the center of this circle. PQRS is a cyclic quad. PQRS is a cyclic quad. Like we can see that the vertices of this quadrilateral are on the circumference of this circle that we are given. So yes, indeed, PQRS is a cyclic quad. Now, redraw the diagram and use the diagram on the diagram sheet 2 to prove the theorem, which states that angle P plus angle R is equal to 180 degrees. So in your answer sheet, on your final, and in your trial, or what do they call trials in Gauteng? I think they're called pre-what, I forgot, but the September paper one, the term 3 paper. So you will be having this diagram. What you will have to do, since you are going to prove that this angle and that angle are supplementary, now you will join the other two angles. Now you will join the radius from the first angle Q to the center O. So you join O and Q, that is a radius. You also join this radius of S if you are going to prove this side. If you were required to prove that Q plus S are supplementary, you are going to join these ones here, OR and OP. But since you are going to prove about P and R, you will join the other two. Fine. Now, you name this angle here O1. This one O1, and this one O2. This is exactly what you will do on your answer sheet. And then now you will say angle O2 is equal to angle O2 is 2 times that one, right? Is 2 times angle P. Why? Because this is angle at the center is 2 times angle at the circumference. Angle at the center is 2 times angle at the circumference. Now, the statement and the reasoning. Okay, yes. Now you go for O1 now. Angle O1 is equal to 2 times angle R. Same reasoning. This is the angle at the center is 2 times angle at the circumference. Angle at the center is 2 times angle at the circumference, and then you get the mark. Okay, and then let's continue now. You will say angle O1 plus angle O2, that is equal to 360 degrees. This one, because that is a revolution. That is a revolution. What is O1? It is 2R. What is O2? It is 2P. is equal to 360 degrees. Now you take 2 as a common factor on the left-hand side. Inside the brackets, you have R plus P is equal to 360 degrees. You divide by 2 on the both sides. Then R plus P is equal to 360 divided by 2. You simply get 180 degrees. Now, you have proved that angle R plus angle P is equal to 180 degrees. Then half mark and half mark here. Then you get a beautiful 5 marks for the proof. I hope it makes sense to everyone and you guys will enjoy that proof. Let's continue to the next problems. The question 11 here. They are saying to us, in the diagram below, AB is a chord of the circle with the center O. D is a point on the circle. OD is perpendicular to AB. Remember, AB was the chord, and O moves from the center is perpendicular to this chord. By theorem 1, this line from the center that is perpendicular to the chord bisect the chord. Therefore, AC is equal to CB, right? Yes. OA is equal to 25. OA, that is the radius, centimeters, meaning also OB will be 25 centimeters, right? Yes. And CD is 18. CD is only this portion here. It is 18. This is the radius OD. It was 25, right? Now we can also find OC by saying 25 minus 18. 25 minus 18, we get 7. Therefore, OC is 7 centimeters. Now, let's go to the question and see what it is requiring us to do. Now, it requires us to calculate with reasons the length of AB, right? Oh, this is beautiful. Now, what are we going to do? You will say OD is equal to OA. They are both equal to 25. What is the reason? This is a radius. This is also a radius. They are both equal because they are both radii. Radii is the plural of the radius. Radii. Now, this is 25. Now, to get OC, we set OD minus CD. We are given CD. What is OD? It is 25. What is CD? It is 18. Now 25 minus 18 is 7 centimeters. We want AB, but we can use Pythagoras theorem to find AC, right? Okay, we will say OA squared is equal to OC squared plus AC squared, right? What is the reason? It is a Pythagoras theorem. What is OA squared? 25 squared is equal to OC 7 squared plus AC squared. That is the unknown. Now 25 squared, 625. 625 minus 49, which is 7 squared, is equal to AC squared. Now I get 576. 576 is equal to AC squared. We want AC, not AC squared. We'll put the square root 576. Then AC is equal to 24 centimeters. That is AC. Remember, we want AB. Now you will say AC is equal to CB. Why? By theorem 1, a line drawn from the center perpendicular to chord bisects the chord. Therefore, AB is equal to AC plus CB. That is equal to 24 plus 24. That gives me 48 centimeters. Then you are done calculating the length of AB. Let's move to the next one. Here they are saying in the diagram below, QOB is the diameter of this circle with the center O. Okay. Now let me erase this. We are also given that PR is parallel to QB. And QB is perpendicular to RS. And angle PBQ is 25. Okay. PBQ. This angle here is 25 degrees. PRS are points on the circumference of the circle. Now, DRCPT, is there any diameter? Yes. We were given that the line QOB is the diameter of this circle. Therefore, now we will go straight to that diameter. We will look for that angle that is subtended by the diameter, which is this one. By that theorem in grade 11, we know that this is the right angle because it is angle subtended by the diameter or angle in a semicircle, right? Yes. And then we are done with DR, the radius. This is the radius OS and OR is the radius. Therefore, ORS is an isosceles triangle. Therefore, this angle will be equal to this angle. Reason being angles opposite equal side. Okay. And then this is also a radius. This is a radius. This and this are equal. Therefore, this angle and that angle are equal. Angles opposite equal sides. And this is also equal to this. This is forced to be equal to this. Reason being angles opposite equal sides. Okay, we are done with the radius. Okay, see the cyclic quad. Oh, this is a cyclic quad as its 4 vertices are on the circumference of the circle. This angle and that angle are supplementary. This angle and that angle are supplementary. And we can see this forms a bow tie shape. Therefore, this angle will be equal to this angle, reason being angles in the same segment. And this angle is equal to that angle, excuse me. Okay. We are done with C. P parallel lines. We have these parallel lines. This is equal to this. They form my beautiful Z here, alternating angles. And this and this, they form my beautiful Z here, alternating angles. Okay, since these lines are parallel, they form U. This angle and this angle are supplementary co-interior angles, and also this and that as supplementary co-interior angles as well. Okay, we are done with parallel line, the theta tangent, we don't have a tangent here. Now, let's quickly jump into the questions and see what we can have. 11.2.1 says to us, determine with reasons 3 other angles that are equal to 25 degrees. Oh, this is beautiful. This is beautiful, beautiful, beautiful. We already saw which angles are equal to this angle. These are parallel lines. We said this is our Z. This angle is equal to this angle. So we will say P is equal to angle B, PB, Q is equal to 25 degrees. Alternate angles. Why? Because PR is parallel QB. We said this is our bow tie, right? Therefore, this angle will be equal to that angle. Now, angle Q, no, not Q as such, but angle R, Q, O is equal to and that angle there. This was not supposed to be P, it was supposed to be RPB. RPB. So I will have RPB is equal to 25 degrees angles in the same segment, same seg. Okay, now this and that form my Z. Now angle PRQ is equal to RQO is equal to 25 degrees. Why? Because those are the alternate angles. Why do I say so? Because PR is parallel to QB. Now you will get your beautiful 6 marks. You get for the statement, reason, statement, reason, statement, reason. 6 marks. Okay. Let's go to the next one, 11.2.2. Determine with reasons the size of angle ROB. ROB, which is this angle here. This one. This angle here. So how are we going to find that angle? It is 2 marks. Okay, let's have a look. We have this angle. We have that angle. We have this angle here. We have that angle. Okay. If we have this angle, then we have this angle here. And then now we can find this angle as well here. And then after finding this one, we can find that one. I'm not sure if what I'm talking about makes sense. This angle and this angle are supplementary. These lines are parallel, meaning these angles are quaternion. Therefore, I will say angle PRT is equal to 90 degrees, because this 90 and that 90 will give us 180 degrees. Now I will say quaternion angles, right? Yes. This one is 90 degrees. This one here, because that is 25 there, forces this one to be 25 because these are the radii. Therefore, Q RO is equal to 25. Reason being angles opposite equal sides. So this is 25. This is 25. What is this angle here? That angle is ORT is equal to 90 degrees minus 25 minus 25, which is minus 50 degrees. It gives me 40 degrees. Now, we are having this angle here as 40 degrees. Now, to find ROB, which is this one, we will say 180 degrees minus this 90 minus this 40 here. So ROB is equal to 180 degrees minus 90 minus 40. I get 50, probably 180 minus 90 minus 40. I get 50 degrees. Reason being interior angles of a triangle are supplementary. So this is the answer for 11.2.2. But probably there is a shorter version of answer to calculate that angle. But there are many ways to kill a cat, guys. Even if you used some other method, you are still more than welcome. Let's go to the next one. B, to calculate the size of angle ORT. ORT. Oh, we already did that. ORT here it is. You can just take this answer, you paste it here. Okay, let's go to the next one. See, it wants ROS. Excuse me. Okay, with this one, this is a radius. This is also a radius. These lines are equal. Therefore, these angles are equal. Then you will say angle OST is equal to ORT, because those are the angles opposite equal sides. Therefore, if we are having 40 here, to find ROS, you say is equal to 180 degrees minus this 40 and that 40 is equal to 100. 100, reason being interior angles of a triangle are supplementary. Then the last one, we are required to determine with reasons the size of RPQ. RPQ, which is this one. Okay, with this one, how can we go for it? Okay, we said this angle, we found it, we said that angle RPB is equal to that angle, meaning this is also equal to 25, right? You will say RPB, is it RPB? Yes, is equal to 25 degrees, is equal to that one, reason being angles in the same segment, right? Which is here. So if this angle is equal to 25, angle QPB is equal to 90 degrees. We mentioned that when we were using the RCPT, that it is angle in a semicircle. Angle in a semicircle. Therefore, RPQ is the sum of this 90 and that 25. So 90 plus 25 gives me 115. So angle RPQ is equal to 115. Then you are done with these problems. I hope now everything made sense, and I also hope that you guys are enjoying these lessons. Now we can end here for this one. We will meet in the next one when I will be continuing with these problems of this